The ultimate aim of a computer vision is image analysis. Here, an input image is passed on to a image processing block where we come across with certain activities like enhancement in the spatial domain, which may be a gray level transformation, histogram processing, spatial or frequency filtering. Apart from it, we do also involve with image smoothing, sharpening, noise removal and morphological operations. After the enhancement stage, we deal with the image segmentation, where the partitioning of an image into some homogeneous connected region happens here. So this image segmentation is playing a vital role in the computer vision problems. So we do get here as an isolated objects here as an output. The next stage that comes here is the feature extraction. In the feature extraction, we do face with a representation and description of the features in the form of a vector. That is nothing but the feature vectors for a data in the image. Next, finally and ultimately we can able to recognize the object that are present in the images after the classification stage. So this generally happens in the image analysis. So let me discuss about the image segmentation part now. So this image segmentation is nothing but it is isolating a specific region of interest, right? And you can see here, so in the diagram which I have depicted here, I am isolating the animal here from the input image which is given to me, right? And partitioning the images into the meaningful entities. Like for example, some here in this image, I am partitioning the image into meaningful entities, like it is some kind of a breed of dog and it is some kind of breed and it is other breed of a dog. So meaningful entities I have done the partition. And also in the image segmentation is used for the image analysis where an image is subdivided into disjoint regions of interest. So all these things you can see here. So this is the image segmentation that is happened by taking biomedical images into the consideration here. So after the segmentation, it is used to do certain activities like tumor detection or any abnormal thing is present in our organisms, right? And this is the given image and this is my segmented image. In this way, the image segmentation will play a crucial role in any computer vision problems. So these segmentation algorithms generally are based on two kinds. One is based on the discontinuity principle and one will be on the similarity based principles. So in the first kind of discontinuity based, we partition an image based on the sharp changes in the intensity. And in the next one, in the similarity based, we will partition the image into regions that are similar according to a set of predefined criteria. So that means in broadly I can I can depict you that image segmentation is broadly classified as discontinuity based as well as the similarity based. Again, in the discontinuity based image segmentation process, we do also have to encounter with some kinds, that is point detection, line detection and edge detection. Why? Because these are the sharp change of intensities in the image will be normally happened by these kind of attributes that are present in the images. And coming to the similarity based, we do have some classical techniques as well as the learning techniques. So by using these classical and learning techniques, we can able to partition the image into the meaningful entities. So in the classical techniques also, we do have some threshold based, region based, that means split and merge, region growing, all will be coming under the region based segmentation. Next is active counter, that is nothing but snakes, and watershed based algorithms. So in the learning techniques, we are going to see the neural network techniques and some machine learning techniques which are highly helpful in segmenting the input image. So let us discuss about the threshold based segmentation process. So in this threshold based segmentation process, it is the context of a binary image actually. Like in this image model, the objects in the image differ in the gray level distribution, because you can see if I have taken this as my input image, so like there are some kind of background and there is a foreground. In the foreground you can see some objects, so I cannot tell you that all the objects giving you the same intensities, right? Because it is a grayscale image, as I have said you, each and every pixel in a grayscale image may vary, or it may give us the intensity starting with 0 and it end with 255. That means in between the 0 to 255 range, the objects in the image may have any kind of variation in its intensities. So the thresholding is one of the important approach here for the image segmentation, because it ultimately results in the binary image. So let me take this is my input image. Okay, so the objects are present here on the uniform background, which is black in color. And for this one, I am computing some histogram for this given input image. So based on this input image, I get here the histogram where this y-axis tends to the number of pixels and x-axis gives me that image intensity. Okay, so that means the image intensity starts from 0 and it is having the highest value of 255. So 255, wherever the pixels which carry the 255 has its intensity value is nothing but those are bright color or white pixels, and the pixels which carry intensity as 0, it indicates that it is a black pixel, right? Okay, so how many number of pixels are having so and so intensities gives me the data of a histogram for a particular image. So here I am having many number of black pixels in this input image, right? So the many number of black pixels I am having here means it is a background. So ultimately I am having more number of black pixels. So the number of black pixels are heavy here. So I got the strength, the volume of the pixels here the highest when compared to the volume of the pixels which carry the brighter part in the image is less when compared to the pixels which carry the darker information, right? So this is the histogram map for the corresponding input image. Now based on this histogram map, I can compute the and appropriately and I can find even the threshold appropriately, right? So after this one, I will be doing the thresholding for the given input image. Ultimately, I get here the binary image, right? So actually for this input image, this is the corresponding threshold. So there will be an appropriate threshold will be finded out here. By using that threshold, I am able to get here a black and white or a binary image. So if g of x comma y is my binary image, so the binary image will be having only black and white as its attributes. So g of x comma y equal to 1 means it is a foreground. That means the input image whose pixel value is greater than the threshold value gives me a logic 1. And here if it is less than the intensity value of any pixel, if it is less than the threshold value, it gives me a 0. That is a background object. So it is represented by black in color. So this image is nothing but it is some boundary detection. Okay, this I will discuss you in the further slides. So here a question will be arised to you all. I have here an input image and this is my corresponding histogram map, and this is also an input image. Its histogram and it is an input image, grayscale image, and it is its histogram map. Now it is your job to find out the black and white image for these three images. Apart from the single threshold, we do have a concept called multi-level thresholding. So this multi-level thresholding is a process that segments your gray level image into several distinct regions. As you can see from input figure to output figure, the same thing can be observed. So this technique determines more than one threshold for the given image. So this image should have to undergo some histogram where we have to find two thresholds, right? So after finding the two thresholds for the given image, we are going to segment this image into certain brightness regions where we get here one background, like because this black color you can consider it as a background here, and we do also have a two or more front ground or foreground objects, like because this is one foreground, the white is pure foreground, and some other pixels are some other variations like the big, because you can see in the figure itself each and every pixel. So this location of pixels is completely white, and this location of pixels are giving some gray level values, and this location of pixels are giving some other gray level values. That means a point here in the image x comma y, this because this is my input image f of x comma y. So a point x comma y belongs to an object class if t1 is less than f of x comma y is less than or equal to t2. That means here t1 and t2 are nothing but two thresholds what I am taking. So I may have one or more object classes. So you can see here this object class is pure white in color. That means f of x comma y is greater than t2, some threshold. For example, let me take if it is a grayscale image, right? So this threshold t2, let me take a value of around 180. So if the pixels which are having an intensity values in the input image more than 180 are considered as some white object here. Okay, so this is one object, and let me go with a value of t1 as 120 or 110, some around. So the pixels which are in between 120 to 180 all comes under some gray level. So this is the one what I have indicated here, you can see. So that means two different objects I have faced after the transformation. After the transformation, that is nothing but after the application of your multi-level threshold concept. So to background, that means if f of x comma y is less than or equal to t1. So let me take the value as I have taken the value of t1 as 120. So who are the pixels with brightness levels as less than or equal to 120? They will be coming under the black object. So the same thing I have depicted here. You can see image with dark background and two light objects. So this is completely white and this is some light shade. Okay, of course it is a gray shade actually. So this is the concept of your multi-level thresholding.